Algebra 1, lesson 63, product of square roots rule and repeating decimal. So the product of square roots rule is something that we've kind of indirectly talked about in previous lessons, which is that if you have a square root, you can factor it, look for groups, and then those groups will tell you what the answer is. Now, what that concept is based on this product of square roots rule. And simply, all that we're saying is, if we have the square root of 16, for example, well, I know that 4 times 4 is equal to the square root of 16, so I could rewrite that as the square root of 4 times the square root of 4. Right? Same number. If I were to multiply these, I would get square root of 16. So all the square roots, product of square roots rule tells us is that we can rewrite these numbers. And then if you remember our rule of square roots, square root of 4 times square root of 4 is just going to equal 4. So our answer is 4 for the square root of 16. Now the way we're going to use this is in the grouping method, which is what I showed you in the previous video, where you start factoring 16. If you're really smart and you factor it into 4 and 4, you can stop right there, because then you would get 4, 4. That's a pair. That satisfies the group number, which is the invisible 2. So that leads us to the answer 4. Now let's say you didn't stop there. Would it still work? Well, let's try it. Let's take square root of 16, and let's say we did 2 and 8. Well, 2 is a prime number, so we have to stop. 8 is going to be 2 and 4. 4 is going to be 2 and 2. So now I have 2 groups of 2. So that turns into the whole number 2 times the whole number 2, which would give me 4. So it still works. Now let's apply this to imperfect square roots, or large square roots. We'll do an easy one to start. Let's say we have the square root of 50. Square root of 50. So I'm just going to start a factor tree. I get 2 and 25. Then 25 factors into 5 and 5. I have a group of 2, so that becomes the whole number 5. And then I still have this 2 here. So this one, if it can't group out, it remains trapped in the radical. So my answer is just going to be 5 times the square root of 2. And all we've done is we've rewritten the number in an easier form to do math with. So that's all that we're learning how to do. We're learning how to rewrite square roots using this square root rule. So we'll do one more large example, and we'll move on to repeating decimals. So let's say we have the square root of 108. So if we remember, 108 is equal to 9 times 12. So I'll factor that into a 9 and a 12. 9 factors into 3 times 3. 12 factors into 4 times 3. 4 factors into 2 times 2. So now I start looking for groups of 2. I've got a group of 2 here. I've got a group of 2 here. And then I have a lonely 3 right here. So what this turns into is it turns into whole number 3 times whole number 2 times square root of 3. If I simplify that, 3 times 2 is 6. We cannot multiply those, so I get 6 times the square root of 3, and that is my final answer. I've successfully rewritten or simplified the square root of 108. Now let's talk about repeating decimals. Repeating decimals show up when you have when you have fractions that are usually based out of 3s. It also works with 8s, I believe. But there's a few square roots they want you to memorize. Before we do that, I'm going to go ahead and demonstrate one. So let's say we have the fraction 2/3, and I need to write this as a decimal number. I'm going to turn it into a division problem of 2.00 divided by 3. You know, I'll even go to a third zero just because. I put my decimal point up top. I put my 0 in front to be polite, and then 3 goes into 20. Was it 3? No, 6 times. Thinking backwards. So 6 times 3 gives me 18. I get 2. I bring down a 0. And we have the exact same problem again. Which is, how many times does 3 go into 20? Well, it's going to be 6 again. I'm going to get 18 again. I'm going to subtract. I'm going to get 2 again. I'm going to bring down another 0. I've got the same problem again. It goes in 6 times. 18. 2. Bring down another 0, so that way we're not writing 6, 6, 6, and you guys don't freak out at me. 6 again. 18. 2. Excuse me. And so we see that this cycle is just going to repeat forever and ever and ever. So the fraction 2/3 is always going to give us the decimal 0.666 repeating, or we could just put 0.6 with a line over the 6. Now 2/3 is one of four fractions or repeating decimals your book needs you to memorize. And it's good to have these memorized. We'll probably memorize more than these 4, but these are the 4 for now. 1/3 is always going to be 0.3 repeating. 1/9 will always be 0.1 repeating. 2/3, which we just did, is 0.6 repeating. And then 1/6 is 0.16 repeating. Now notice the line is only over the 6, which means that the 1 starts and then the 6 starts the repeating process. So you'll have a few problems here and there that'll tell you, we'll go to this example right here. D. What fraction using counting numbers equals the repeating decimal 0.16 with a line over it? And that one is actually 1/6. So if you memorize these 4 fractions and their decimal counterparts, you'll have no problem with these questions. And then it's good to have these memorized because it gives you a good number sense as far as decimal numbers go in relation to their fraction counterparts. If you have any questions, let me know on Moodle, and I will see you in class.